All right, so this is our robot lab. Our robot lab has gone through some changes. We use spheros and ollies. As a matter of fact, you'll see the island of misfit toys. And I don't get rid of them for a purpose. They're broken, fix them, take them apart. If you've never seen the inside of an ollie, you can open it up here later this afternoon. But it's just really cool because the kids can get in there, can see how it works, they can see the motors, they can see the electronics, they can tell most of them know that there's a wire broken. Like the black ollie, there's a wire broken. I don't have soldering irons, but if a kid wants to take the ollie home and solder it, take the ollie home and solder it. I actually throw out the challenge that if that black ollie operates when I come back on Friday, you get to keep it. So I mean, they tend to tear into it and do that stuff. So even with those simple robots, there are lots of challenges that we can do with those, focused on programming. We don't just want you to drive the robots, we want you to program and code. That's the important part. I don't care if you know how to use an iPad to make it go forward. I want to know that you can build a maze and program it to go through the maze, and when it goes past the yellow cup, it turns yellow, and those kind of things. So we do have a brand new robot in our lab. This is called a DoBot. Now the DoBot is a robotic arm that has lots of different attachments that you can put on the arm. You can program it. It's got a remote control, wireless controller that you can do things with. Right now, we have the pen. Now, I will say that I'm a little bit disappointed because I challenged, so Ben set this one up this morning, and I challenged him to have it draw the bridge from iRobot, just because I think that's kind of cool that a robot would draw it. But so he had it draw. This is Yetibotics. It's the logo for our robot program. But it's got a pen so it can draw, which is a really cool process. The pen pops out. Get it loose. And then there's a gripper that uses pneumatics. There's a suction cup. There's actually a 3D printer head that can come with it. I'm not going to leave the 3D printer head in the lab because we'll just do the grabbing and the suction. But there are sensors and other things that go along with it. It also has a laser engraver. Obviously, the laser engraver is not going to travel with the lab because you got to have glasses and all kinds of different safety things. So when it's not at a school, maybe we'll use the laser engraver at my office. But so it's a really cool. It simulates an industrial robot arm. It does have the press and play where you can press it and record and set locations and do different things to program it, just like the big industrial robots can do. But then there's also several different types of coding applications that you can use to make the robot do things. So in this lab, we're really trying to focus on this idea of logic, emergency operation procedures. So at our nuclear power station, our power plant operators are probably the most well-trained people in the world. Like at a nuclear power station, you train more than you actually work. So in your rotation, your job in the control center, you do a lot less than your job training. And they train and they train and they train. Our nuclear power plant operators could operate that power plant in their sleep. But they don't. There's like 2,400 emergency operation procedures that they know, they memorize. They understand every step to solve every problem. They're not allowed to. So if there's a problem at our nuclear power station, they go, one person grabs these great big placards that have the flow chart. And then they do this three-way communication to go through the logic. You know, they say, do this switch, what happens? Red light, do this. They go through this whole entire emergency procedure, even though they know how to operate it. Why do you think we use emergency operation flow charts instead of humans? Flow charts don't have emotions. They don't forget things. So it helps eliminate human error. And so that's what logic is. It's this scientific process to accomplish a task. And so we go through this, we can tie the operation of a robot arm to the operation of a nuclear power plant through emergency operation procedure concepts. And the idea of logic, and using that logic to improve our likelihood of accomplishing the task safely. So this robot is a really unique way for us to show skills. Now, in PPD, I'm trying to think, I think we have one robot arm system that helps us do poles where we can't get a truck. And we have some overhead crane systems, but we don't really have any programmable robot arms like autonomously doing anything in our power plants. Again, we're not teaching you how to use a specific robot. We want that concept behind the system. So this is a fairly new process, so we'll be excited to see what the kids can come up with and to do with it, but we want to see what they can make it do. And that's the unique process behind this. We do ask that if you get a ollie or a sphero to work, that you use it in the designated area. Especially here, pretty soon we're going to show you the virtual reality machine. And driving the robot near the virtual reality machine isn't really safe. A little round sphero robot bumping up against somebody that feels like they're on top of a wind turbine, it kind of freaks them out, and it's very dangerous. So we try to make sure that we drive the robots in the appropriate location.